Question number 5 taken from June 2014, HSC Advanced Level Maths, P3. The variables x and theta satisfy the differential equation 2 cos square theta dx over d theta is equal to root of 2x plus 1, and x is equal to 0 when theta is equal to quarter pi. Solve the differential equation and obtain an expression for x in terms of theta. Okay, here is the equation. Right, so we're going to separate the variables, but before we do that we have to observe certain things here. This is theta, and theta is down here, so what we can do is say 1 over 2 cos square theta with respect to d theta is equal to, this one goes down, this one goes up, this one goes down, and dx is multiplied. When you send on the other side, it's going to become root of 2x plus 1 times 1 over dx, but if we put dx on top, that's going to become 1 over 2x plus 1 and the root of that. Therefore now from here we can integrate easily. So we've already separated the variables now, so what we can do is integration of half, okay, 1 over 2 cos square theta d theta is equal to integration of 1 over 2x plus 1 to the power of half dx. Right, now half can go outside, and then we're left with 1 over cos square theta, which is sec square theta with respect to theta is equal to, okay, integration of 2x plus 1 to the power of minus half dx. In other words, integrating sec square theta, you're going to end up with tan theta, alright, is equal to, if you integrate this one, you're going to have to add 1 here. Minus half plus 1 is half, and then you divide by half. Okay, if you divide by half, it's going to become 2. Alright, so what we're going to do is 2x plus 1 to the power of minus half plus 1, divide by half, and then the derivative of 2x plus 1 is 2, so divide by 2 again. Now, this is half tan of theta is equal to 2 divided by half is how much? 1 here. 1 divided by half is 2. Okay, and 2x plus 1 to the power of half divided by 2. Alright, plus a. And therefore you have half tan of theta is equal to, these two go out, you have 2x plus 1, alright, plus a. You can say square root of 2x plus 1 plus a. Right, now we are told that x is equal to 0 when theta is equal to pi upon 4. So we're going to replace that here. We're going to say okay, half tan of theta, which is tan of pi upon 4, is equal to root of 2x, 2 times 0 is 0, root of 1, alright, plus a. Because 2 times 0 is 0, 0 plus 1 is 1, and we have root of 1. Okay, what is this? Tan of this, this is 1, so therefore half times 1, sorry, that should have been half times 1, okay, is equal to, root of 1 is 1, alright, plus a. So you have a is equal to 1 times half, 1 times half is half, and send the 1 on the other side, so therefore a is going to be minus half. Now if a is minus half, then what do we have? Okay, so we're going to have then this, half tan of theta, half tan of theta is equal to root of 2x plus 1 plus a is minus half. Okay, so what else can we do here? We can send this on the other side, and therefore it's going to become half tan of theta plus half is equal to root of 2x plus 1. You take away the root, that's going to become square, so half tan of theta plus half to the square is equal to 2x plus 1. You expand that and you're going to end up with 1/4 tan square theta, 2 times the whole thing, it's going to become plus half tan of theta, 1/4 to the square is plus 1/4 is equal to 2x plus 1. Now what else can we do? We can send this on the other side, becomes 1/4, alright, tan square theta plus half tan of theta, okay, plus 1/4, send the 1 here, 1/4 minus 1, okay, is minus 3/4, and the 2 goes there, becomes divide, so the whole expression here, you divide by 2, is going to equal to x. So x is going to be 1/4 divided by 2 is 1/8 tan square theta plus 1/4, because half divided by 2 is 1/4 tan over theta minus 3/8, isn't it? So you can say 3/8. Alright. So what else again? Is that x is going to be then 1/8, 1/8, 2/8. So we can say 1/8 outside, and you're going to end up with 1/4 tan square theta plus 2, because 2 times 1/8 is 1/4, 2 tan of theta minus 3. Now this is a quadratic expression, so you have x is equal to 1/8. If you put that in the form of completing the squares, you're going to say tan of theta, you open a bracket, you say tan of theta, 2, okay, divide by 2 is 1, so you're going to say plus 1, then you square. If you re-expand this, that 1 here is going to appear in your expansion, alright, so you're going to have to subtract it, so minus 3, then plus 1, plus 1, okay, plus 1 to the square is 1, and since this was not there, so you're going to have to minus it, right, therefore, what can we say? That okay, x is equal to 1/8, you multiply this, tan of theta plus 1 to the square, minus 3 minus 1 is minus 4, so you have minus 4 times 1/8, that's going to become minus half. Okay, I hope you are comfortable with that here. You see, the reason I have minus 1 here is because when you expand this, it's going to become tan square theta plus 2 tan theta plus 1. Okay, and if you do that, okay, let me just separate it here. If you expand this, it's going to become tan square theta plus 2 tan of theta plus 1. And we have this, you have this, but you don't have the 1. That's why we have to take this one away. Alright, so the reason here why I've taken it away. And here we are, x is expressed in terms of theta.